Hey everyone, today we're going to go over the graphing linear equations, and this is graphing that you've already learned how to do in the past, so this is going to be a review. It's a very important topic that you're going to need to know to carry on over into your high school math career. Excuse me. So let's just get started here. We're just going to do a few graphing problems for practice today, and we have for our first example, we have two different equations that we're going to be graphing. And you look, they're pretty identical, right? The only couple of differences is this is a negative 2x, whereas the other one is a positive 2x. And this is a plus 4, whereas the other one is a minus 4. Okay, so I'm going to graph them in their respective colors. Excuse me. So if you recall, this equation is in slope-intercept form. And when it's in slope-intercept form, it is easy to graph most of the time, right? So this is your b value, right? So slope-intercept form is y equals mx plus b. Your b value is where you begin on your y-axis, also known as your y-intercept. Where does it intercept my y-axis? Well, if you're looking at our example here, our b value is a negative 4. So we go over to our graph, our y value starts at negative 4, because you remember this is the y-axis and that is the x-axis. So it begins at negative 4. So the other thing we're going to look at is our slope. So m stands for slope. This is why it's called slope-intercept form. I have a slope and I have a y-intercept. So makes it super easy to graph. And our slope, if you recall, it's easiest to think of it as rise over run, right? And in other words, your vertical change or over your horizontal change. So if it helps you to draw a slope triangle, by all means do it. So let's take a look at our slope here. Our slope is 2. But it's always easiest to write it as a fraction. So we're going to say m equals 2, and to put that as a fraction, you put it 2 over 1. Okay, so our vertical change, our rise, vertical change, it goes up a positive 2, and our horizontal change, our run, it goes to a positive 1. So let's go back and start right here on our graph. It begins at a negative 4, and the rise is a 2. So I'm going to count 1, 2. It goes up 2, and then I pause, and then I'm going to run a positive 1, and a positive 1 goes to the right 1, so it's right there. Okay, all I need is 2 points. Once I have 2 points, I get a ruler, and I basically connect the dots. So what you can do, if you want to make life a little bit easier, you can continue your slope from each one of these points. So again, you go up 2 over 1. Up 2 over 1. If you keep on going that, you'll have like enough lines that'll make it much easier to trace. Right? So I'll go ahead and erase those arrows, and now I'm going to create a line. There's my first line. Okay? And let's compare that to our blue equation. Okay, so a blue equation, if you notice, the y-intercept, our b value, is a positive 4. So it's going to start right there. And then my slope, my m value, is a negative 2. So it's a negative 2. If I turn that into a fraction, I just put it over 1. You can turn any fraction or any number into a fraction by putting it over 1. So my rise is going to be a negative 2. So how do you rise in negative 2? Well, you're not going to go up. You're going to go down now. Right? And then my run is a positive 1, so I'm going to move over to a positive 1. And there you go. I have 2 points. And I technically could stop there. Right? If I really wanted to, I don't have to go any further, and I can just stop. And there's my second line. I'm done. Okay? So you got to know where your x-intercepts, or excuse me, your y-intercepts are, which is your b value, and then you're going to have to know how to find your second point after that, which is going to be your slope. You do your rise over your run, and that's usually the quickest way to do it. Okay. All right, let's move to the next problem. So these next two problems are going to be a little bit trickier at first glance, but it's super easy to do. Again, I'm going to follow the colors here, right? So I'm going to do the blue equation will be in blue, the red equation will be in red. So the blue equation is x equals -4. Well, you ask yourself, x, where is my x-axis? There it is. Then you ask yourself, what does x equal? It equals -4. Where is -4 on my x-axis? Well, is it right there? No, that's x equals -4 on my y-axis. So I need to go back to the x-axis and find -4, and it's right there. Okay, so these equations, basically, they're special cases, right? Your x is going to be a vertical line, right? Meaning it's going to go up and down, right? So if you're just looking at this equation of x equals -4, well, you know it has to go through your x-axis at -4. Well, is it going to slope like that? Well, it doesn't give you a slope for you to tell you how many spaces to rise, how many spaces to run, right? So it has to be a vertical line, just like that, at x equals -4. That's it, you're done, right? And the common mistake is that, well, students will plot this point at -4, okay? They will say, okay, x equals -4. Well, maybe it's going to be a line that goes through -4 like that. Well, that really doesn't make any sense, because technically you could say, well, x equals -1, x equals 2, x equals 3, and it's that same line, right? So it wouldn't make sense if you drew a horizontal line. So it has to cross -4 through your x-axis, okay? Just like that. So how do I do the equation in red of y equals 2? Well, I'm pretty sure you guys are figuring this out already. If I have y equals 2, it crosses my y-axis at +2. So I'm going to find +2. And again, would that be a good graph? That could be y equals 2. What if I said to graph y equals 4? Well, using that same logic, y equals 4, you could give me pretty much the same exact graph and it wouldn't be any different, right? So that tells you right away that that's going to be wrong. So y equals 2 is going to be a horizontal line that crosses at 2. Okay, that's it. Make sure you guys know the differences between those. Okay. All right, let's move on to the next equation. Y equals 2/3 x minus 4. So I want you guys to pause the video and graph this one on your own. Let me rewrite it for you in case you're not used to seeing that 2/3 like that. It's the same thing, I'm just rewriting it. Y equals 2/3 x minus 4. Pause the video and come back when you're done graphing it. All right, so you should have you began by looking at your b value, which is a -4, which is your y-intercept at -4, which is right there. That's -4. All right, and then your next point, you're going to use your slope, which is 2/3. So you can create a slope triangle, if you will, and go up 2 and over 3, and that's how you get this second point right there. You're always going to start counting wherever your b value is. Okay, so from that b value, you're going to go up 2 and to the right 3, because up is positive and to the right is positive as well. All right, so you have 2 points. You're pretty much done. You just grab a ruler and connect the dots. Easy peasy, lemon squeezy. That's good enough. All right, let's move on to the next problem. This one now is a little bit trickier, right? So the problem here is, you could probably already tell, this equation is not in slope-intercept form. And slope-intercept form is y equals mx plus b. In other words, y is all alone on the left side. It's isolated. So what do I do to this equation to isolate y? Okay, so I want you guys to try to isolate y, get y by itself. And then when you get y by itself, go ahead and graph it, and then see what it looks like. All right, pause the video, come back when you're done. All right, so to isolate y, we're just going to get rid of that 2x and bring it to the other side by subtracting 2x. So when I subtract 2x on my right side, I can't combine them with the positive 4 because they're not like terms, so I write y equals negative 2x and then a plus 4. So that plus 4, the number by itself, is always, we call it your constant. It doesn't have an x, right? It's just plus 4. So that's going to be your y-intercept. Your y-intercept is a positive 4, which is right there. There's that 4. Then your slope is going to be a negative 2. I put it over 1 to turn it into a fraction. And then you'll see that from my y-intercept of positive 4, I'm going to go down 2 and then to the right 1. So negative 2, positive 1. And that's pretty much it. I have enough points to create a line, connect the dots, and I'm done. All right, let's go to the next problem. Similar situation here. Gets a little bit trickier, an extra step pretty much. I want you to, again, put it in slope-intercept form, solve for y, and then graph it. Come back when you're done. Okay, so this situation, we're again going to start off the same way by subtracting 2x. 4 minus 2x, we can't combine them because they're not like terms, so we just rewrite it as negative 2x and a positive 4. But then after that, you notice the left side, I still have that 2 next to the y. So to get rid of the 2, I've got to divide by 2 because it's 2 times y, the opposite of times is divide. And notice I have to divide every single term by 2. Okay, you can't just do it to 1 or 2 terms. You have to do it with every single term. So on my left side, I get y by itself. On the right side, I get negative 2 over 2x is negative x, negative 1x, right? And then 4 over 2 is a positive 2. So I begin at 2. That's going to be my y-intercept. And then my slope is a little bit trickier now. My slope is the number next to x. So some people will make the mistake of saying, well, what's the slope? Slope is going to be x. There's no such thing, right? Or they might say in this situation it's a negative x. The slope is always going to be a number. It's always going to be a fraction. So what number is next to x right now? Well, that's a negative. You don't see a number, so you assume that it is a negative 1, right? And then to turn that into a fraction, you just put it over 1. So now my rise is going to be a negative 1. So going back to my graph over here, I start at 2, but then I go down 1, and then to the positive 1. I go down 1 because there's a negative 1. When it's a negative, we go down, right? So there's my second point, and pretty much graph this like that. Connect the dots. You are done. All right. One more problem here. Same deal. You've got an equation with your x and y on the left side. Go ahead and isolate y, put it into slope-intercept form, and then graph it and come back when you're done. All right, so in this situation, started out the exact same way we started the previous problem. We're going to get rid of that 2x by subtracting it. On the right side, I can't combine a negative 6 and a 2x because they're not like terms. So I rewrite it as negative 2x minus 6. So on the left side, you notice that I still have a negative 3y. Don't forget that negative, it's still there. So it's a negative 3y. Right? So when I bring that down, that means I've got to get rid of that negative 3. So I'm going to divide everything by a negative 3. You always have to do that. And so when I divide, right there, negative 2 over a negative 3, well, the only thing that I can simplify are the negatives. A negative divided by a negative is going to be a positive 2/3 x. Right? And then negative 6 divided by negative 3 is going to be a positive 2. So once again, my b value is going to be a positive 2. Right? So I begin at positive 2 on my y-axis because it's my y-intercept. And now my slope right there is rise 2, run 3, 2 over 3. So this is already in a fraction form for you, so it makes things a little bit easier, right? So from here, I'm going to rise 2, and then I'm going to run 3. And that's my next point. Connect the dots. Done. Easy peasy. All right. Hopefully this is making sense to you guys. A lot of repetition, a lot of same type of problems. And that's it for today, guys. Just make sure you guys understand how to put it in slope-intercept form. And then the key is graphing these two equations, right? So let's just do one last one. This will be our closing problem. I want you guys to graph y equals negative 5, and then x equals, I don't know, 3.5. Okay. Go ahead and graph this on your own. I'm just going to close this lesson out today. Make sure you guys know how to graph those two equations. And if you have questions, you can ask me when we do our Google Meet, but I'm not going to go over the answer right now. All right, guys. Hope you guys have a great day, and I will talk to you soon. Bye.